Today, we're diving into a technology that is, no exaggeration, reshaping our entire world: machine learning. You hear the term thrown around everywhere, but what does it really mean? How does the machine actually learn anything? Well, let's break it all down.
To get us started, let's just think about a quick question. What is the one thing that connects fields that seem totally different, like cybersecurity, how you shop online, and even the future of healthcare? They feel like they're in completely different universes, but there's this incredibly powerful engine driving all of them forward.
And the answer, you probably guessed it, is machine learning. It's this quiet revolution that's happening all around us, finding patterns and making predictions in ways we just couldn't do before.
So, let's really get into it. What is machine learning at its core? How do we actually get from a bunch of data to a machine that can learn something useful?
It all starts with data. We are living in what people are calling the fourth industrial revolution, and it's basically an era defined by just an unbelievable ocean of digital information. And machine learning? That's the key that lets us unlock all the secrets hidden inside that ocean of data.
So you can kind of look at machine learning from two different angles, right? They're like two sides of the same coin. From the scientific side, it's this deep study of learning itself. How does anything, whether it's a person or a computer, use past experience to get better? But then, from the engineering side, it's much more practical. It's about building software that literally programs itself based on the data you feed it.
Okay, but this brings us to a huge fundamental problem. How can a machine make a smart decision about something it has never, ever seen before? This is really the central challenge of learning. The famous linguist Noam Chomsky had a brilliant phrase for this: the poverty of the stimulus. And it makes so much sense when you think about it. You can't show a self-driving car every single possible thing that could happen on a road. You can't show a spam filter every spam email that will ever be written. Your training data is always going to be incomplete.
So if the machine hasn't seen everything, how does it manage to figure out what to do in a new situation? It's not magic. It needs a kind of shortcut, a built-in set of starting assumptions to guide it. And that shortcut is called learning bias. Now, I know what you're thinking. The word bias usually sounds like a bad thing, but in machine learning, it's not just good, it is absolutely essential. A learning bias is just a preference for one kind of answer over another. This idea is so fundamental, it's often called the no free lunch theorem, which basically means you simply cannot learn anything without some kind of bias.
And what's really wild is that this idea is not new at all. In fact, philosophers way back in the 14th century figured out the core of this learning shortcut with a simple Latin phrase that has pretty much guided science ever since.
And it translates to, simple rules are preferable to complex rules. You might know this idea as Occam's razor, and it is hands down the most powerful and universal learning bias there is. When an algorithm is looking at two possible ways to explain something, it's designed to prefer the simpler one. That preference, that bias for simplicity, is what allows a machine to make a really good educated guess when it sees brand new data. Okay, so we've got the main idea down. Learn from data and have a bias for simple answers. So how do we actually do that? Well, let's pop open the algorithm toolkit and see what's inside.
The two biggest players on the field are supervised learning and unsupervised learning. Think of supervised learning like you're studying for a test and you already have the answer key. The data is all neatly labeled with the right answer, so the machine's job is to learn the rules to get from the question to the answer. Unsupervised learning is the total opposite. It's like someone just gives you a huge, messy pile of photos and says, find interesting groups in here. There are no labels, no right answers. The algorithm has to discover the patterns all on its own.
And here's what that looks like in practice. A supervised task could be classification. Is this email spam or not spam? Or it could be regression, which is all about predicting a number, like what's the temperature going to be tomorrow. Unsupervised learning, on the other hand, is about finding those hidden structures. It can cluster your customers into different groups based on how they shop, or it can find associations, like the classic example that people who buy diapers often buy beer at the same time.
All right, enough of the theory. With all those concepts in mind, let's see how this stuff actually comes to life. Where is machine learning making a real impact out there today?
Well, in cybersecurity, ML algorithms are on the front lines. They learn the patterns of what normal activity looks like so they can spot credit card fraud in a split second. They're also amazing at anomaly detection, sifting through mountains of data from all our smart devices to find one little piece of strange behavior that could signal a hack.
And in e-commerce and business, oh, it is everywhere. It's the engine behind those recommendation systems that know exactly what you want to buy next. It splits customers into different groups for better marketing. It can even read thousands of product reviews and tell you if the overall feeling, the sentiment, is positive or negative. And in factories, it's used for predictive maintenance, forecasting when a machine is going to break down before it actually happens.
And it's not just about shopping and business. This is making a huge difference in really critical areas. In healthcare, ML models can help doctors predict diagnoses by analyzing patient data. And in agriculture, they're helping to forecast how big a harvest will be and can even spot diseases in plants just by looking at pictures, which helps make farming way more sustainable.
So machine learning is clearly incredibly powerful, but what's next? Where do we go from here? Well, despite all of these amazing successes, building a machine learning system today is still often more of an art than a science. It takes a ton of experimentation, a lot of intuition, and just a whole lot of trial and error. We're still kind of figuring out the rules of the road.
Which leaves us with this one big, fascinating question to chew on. See, right now, we can design a bridge with incredible precision because we understand the laws of physics inside and out. So when will we get to the point where designing a learning system is just as predictable as building a bridge? That right there, that's the grand challenge for the future of this field. Thanks for joining me.